Hi, I'm going to show you a few things about some basic vocabulary you probably will know and some basic algebra you probably should know. If you don't, it's a chance for more practice. So first of all, this is a straight line badly drawn, and this is a ray off of it. So this makes what's called two consecutive or adjacent angles rather. And these can have measures, and hopefully you recognize that since all the way around a point is 360, across a line, what some people call a straight angle, those two have to add up to 180. So if I told you one of these was, say, 39, you would be able to tell me that the other one, it's a little hard to read, 39, worse to read now, 39, remember that's 39. You'd know that the other one would be 180 minus 39 or 141. However, typically your problems aren't that easy. These are also called supplementary angles, and the way I like to remember that is S for supplementary is straight line. Usually you get a problem like this. Instead of just this, they might tell you that, hey, this angle over here is 2x plus 1, and so therefore you know that those two have to add up to 180, and then you typically create an equation for it. So you get something like 2x plus 1 plus 39. We know that has to add up to 180, and we have to do some algebra on it. So we get 2x plus 40, and made that easy for myself, equal 180. I subtract 40 from both sides. I get 2x equals 140, and then I divide both sides by 2, and I get x equals, not 2, 70. So that is what the work looks like. And so I'm going to give you another one, and I'm going to have you try it. So once again, I'm going to draw a straight line, which is something that looks kind of similar. Got a problem all queued up for me here. And go ahead and try this one. I think this comes out to a whole number, not a fractional answer, not a negative answer. And I'd like you to find out two things. First of all, I'd like you to figure out what x is, and then I'd like you to figure out what that whole angle is. It doesn't be in either order, actually. Okay. The next kind of problem you'll typically have is we had supplementary angles. We're going to have what's called complementary angles. So complementary angles is when you have a right angle, and usually sometimes this will be marked as right, sometimes you'll be told it's a right angle. Marked as right, it's right there. It's a little unusual to do it this way if I'm going to draw an adjacent angle inside, so I get two adjacent angles there. And we know those have to add up to 90. And once again, that stands complementary with a C, just like that's a corner, and most corners on most things like books and things are usually a right angle. So that's how I remember that. So once again, if I told you that this right, I could tell you like this was 10, and you'd be like, well, that's got to be 80. I'm going to make this a little harder. I'm going to say, hey, this one's x plus 3, and the other is 2x. Okay, so I got x plus 3 and 2x, and say, oh, I can turn that into an equation. I can say, well, I know that 2x plus my x plus 3 is equal to 90. And so that means 3x plus 3 is equal to 90. I can subtract the 3 from both sides and get 87, and then divide both sides by 3, and I get x equals, that's going to be 29. Okay, so that's what that work looks like. So I'm going to give you one to try now. So once again, I'm going to draw, I'm telling you it's a right angle, so you know it's got to add up to 90. And once again, these may not be what they look like. This looks like they're both 45. These are not both 45 angles. Okay, and I got x minus 4 for one of my angles, and 5x plus 10 is the other angle. And I'm going to ask you, what is x? And what is the size of the smallest angle? All right, and our last little problem. We have what's called, some books call them vertical angles, which is a weird name, I think, and others call them opposite angles. It's when you have two straight lines that cross that look like something like this. So this one and this one would be called vertical angles, and this one would also be called vertical angles. I'm going to put two dots in there. And the reason I don't like vertical angles, even though most books call it that, is only these two seem like they're vertical. These seem like they would be horizontal, but that's not what they call them. That's a vertical pair, that's a vertical pair. So other books will call these opposite angles. Those are across from each other, those are across from each other, but it's more common to call them vertical angles. Once again, I think it's a terrible name. That happens sometimes. So this one's fairly easy. If I tell you this is 70, you could pretty quickly tell me, oh, well, those kind of look like they're the same. It's because they are. Because this has got to add up to 180, so that's 110. That's got to add up to 180, so that's got to be 70. If this is got to be 110 because they're on a straight line, which means that would also have to be 70. But instead, I'm going to give you a problem like this. I'm going to say, well, this is 2x minus 4. It's a little hard to read. 2x minus 4. And so my equation for solving this is 2x minus 4 equals 70. And this equation might be a little bit easy, but I could give you a harder one. And I think that works out to not a fraction. Sometimes you will get fractions. Generally, if I get a fraction, I double check my work because most books fix it so you don't have a fraction. Let's see, add 4 to both sides, I will get 74. And I divide both sides by 2, and I get, what is that, 35, 37. Hope I did that right, 37 degrees. All right, I'm going to give you one, try yourself. So once again, I'm going to draw some vertical pairs. I'm going to tell you this is 100. I'm going to tell you this is 5x minus 10. And so this is your problem. And so I'm not going to ask you what this is because you should already know what that is, but I am going to ask you what x is. What's the value for x? Okay, thanks. Good luck.